Welcome. Looks like you've made your way to the Sumo Robot Fighting Competition. If you're going to pick a favorite, let me show you why our robot's the best of the best. We are Team 3.2 of a design methodology class comprised of 5 members, including
Gavin Reitz,
Josh Peters,
Kevin Donches,
Jeffrey John Jacob,
Kairui Tang.
You made your way here, so you must know the rules, but do you know the strategy? You want to be looking out for 4 things in a robot. One that can be modified, that can defend itself, displays efficient movement in the ring, and an additional wow factor that surprises both the opponent and the audience alike. Let's show you what we're offering.
We'll give the robot a competitive advantage.
Modularity and flexibility are the 2 words I'd use to describe our team's mindset when building the robot. Getting a good idea and working through it for weeks only to realize that there's a flaw that forces you to restart, that can be devastating to the creative process. Every piece in our robot was built knowing that we might tear it out and redesign it completely. And we did that several times. From top to bottom, we've considered things like our opponent's designs, our own testing, and even the flaws that we only notice after assembly. The point of all this is that we're competing, and our competent classmates, they're competing too. In a competitive environment, strategies are constantly changing and evolving, and the ability to take a piece out and completely redesign it on a whim, that's essential to a consistently superior robot.
We'll give the robot a competitive advantage.
Every matchup begins with each robot stationed to the right of each other in the ring. Our code is programmed so that the robot turns right in search of the opponent immediately after being turned on. The code can be reprogrammed depending on the rules and the setup of the competition. We ran multiple experiments to find the maximum speed our robot could turn before not being able to detect the opponent. Compared to the first competition, our new code's average time to detect the opponent is in the top 20% of the class.
We'll give the robot a competitive advantage.
Everyone has heard the phrase defense wins championships. This is what motivates our team's decision to include 4 flaps around the base of our robot, adding protection to every side. Other robots out there typically have one side protected, but they leave the other 3 sides open to an attack from behind. This means that their electronics could be rearranged and damaged. Our flaps easily attach to a band that goes on top of the modular box. This band can be customized to fit any design such as other geometries or internal mechanisms.
We'll give the robot a competitive advantage.
The last aspect of a robot's defense is the ability to distract our opponent's LED sensors. In an ordinary match, if a robot approaches the white boundary line, the LED sensors would detect it and attempt to avoid it by backing up or turning around. We made this common response an advantage for our robot by surrounding it with its own white boundary line. By attaching printer paper to the end of each flap, we ensure that the opponent will drive over artificial boundary and respond by retreating rather than charging.
At the end of the tournament, 1 robot will come out on top. We've demonstrated that ours is both defensible and dangerously efficient out of the gate. It can play the opponent's abilities against themselves and still be modified at a moment's notice. We may be going up against a lot of dangerous and well-built robots, but ours has the most flexibility and potential to overcome whatever is put in front of it. Besides, if we lose the first tournament, our modular robot will give us the fast response time to make adjustments and be ready for the next tournament.
Kevin, you know there's only 1 competition, right?
Wait, so a full semester's work and we only get 1 chance to show it off? Who makes these rules?
Oh, we got, yeah! Woo! Let's go, baby!